Welcome, class, to the Intro to Java Programming. In this lesson, we'll review properties and access modifiers. Remember, our class has three main areas of interest: constructors, methods, and properties. We built the payroll class to perform payroll responsibilities. We also have a method to get the net pay amount. Today, we'll work with properties, but first, I think it's important to discuss access modifiers. The code you're about to see is intended for novice developers to explain concepts with properties and access modifiers. Access modifiers are how you can restrict access or scope to classes, constructors, properties, and methods. The options are public, default, protected, and private. For the upcoming lessons, we'll focus primarily on public and private. Let's say you own a bank that is open 24 hours a day. The front door is considered public for all customers. Should we allow anyone public to have access to the vault? The vault is private. Only employees in the bank will have access to the vault. The bank in this example is a class. The bank class is public for anyone to access. Let's say enter vault is a method in the bank class that we want to restrict access. Private means all other classes will not have access to the enter vault method. Methods inside the bank class will have access to the private enter vault method because they belong to the bank class. In our physical bank, a customer can deposit money. Only the bank employee can take money into the vault. Deposit money is a public method. Enter vault is a private method that can only be called by methods inside the bank class. Here is the My Customer class. Like a real bank, customers can perform public actions like depositing money with an employee teller, but not private actions like entering the vault. Notice the compiler error. Let's comment this out. Outside the bank building, but still on the bank property, is a 24-hour ATM machine that dispenses money. Again, the use of the ATM machine is considered public because it is always open for anyone to access. Inside the ATM machine is a locked door that holds all the money the ATM machine will dispense. Access to this door is considered protected. The public cannot open this door, but employees of the bank will have access to this door. The real bank property is like a Java package, a collection of Java classes. The My ATM machine is another public class that is found inside the same package as the My Bank class. The ATM door that holds the money is like a method of the My ATM machine class. By assigning protected to that method, only classes in the same Java package will have access to the code. Classes outside the Java package will not have access to the method's code. This means that a My Bank class method can access the locked money door in the My ATM machine class. Notice no compiler error. Inside the bank class, what if we did not declare an access modifier for a method? Not public, not private, but they would be considered default. Default is like public inside the My Bank class, but private to all other classes. Notice the compiler error. Let's comment this out. It is good practice to declare public or private in your class and not use the default access modifier. Here is our basics project in IntelliJ with all the code used in the previous examples. Let's review some sample access modifier code and unit tests for the bank, ATM machine, and customer classes. In the project panel, there are 4 new packages and 5 new classes. Here is the My Bank class. Here is the My ATM machine class. Here is the My Customer class. Here are the unit tests for the My Bank class to prove how the access modifiers behave. And here are the unit tests for the My Customer class. Take some time to run a few tests and make changes to the code to get a better understanding of access modifiers. Inside the My Bank test class, be sure to understand why deposit money, that calls the My Bank class, is allowed to enter the vault. However, you get a compiler error if we uncomment this line and we explicitly try to make a call to enter vault. Let's go back to our payroll class and add a few properties. What is a property? Simply put, a property is a variable that is used by the class. Sometimes a property is called a field. All objects in the physical world have properties. Some we care about more than others. Some examples of a property in a bank could be the name of the bank, the number of teller stations, the contents of a safety box, the amount of money in the vault, or the amount of money in each teller drawer. Some properties can be changed while others should not be changed. Like methods, all properties will have an access modifier that can be public or private. Time for a Coach Joe challenge question. What properties or class level variables should be used by the payroll class? Correct. Hours worked, hourly pay rate, and total taxes. Let's go to the payroll test class and create a new test that passes these three values to the constructor and prove the class exists. Let's collapse some of these existing tests. Now we have a test that will prove we can create a class with three parameters in the constructor. Let's add these three properties to the payroll class. Create all three properties with an int data type and make them private. Next, let's create a constructor that accepts three parameters and assigns them to the class properties. The keyword "this" is a reference variable that refers to the current object. In this example, we're storing the parameter values into a property of the payroll class. This.HoursWorked means store the value in the hours worked property of the class that is executing the code. Payroll is the class executing the code, so this equals payroll class. Also, consider if we did not use the "this" keyword. Hours worked equals hours worked. What happens? We just said the incoming parameter value is equal to itself. That's not what we wanted. Correct. Using the keyword "this" makes it clear that we're setting a property of the class. There are four common ways a value of a property can be set. The first and most recommended is by passing the value in a constructor. The second is by assigning a value in any method. The third is by using a setter. A setter is used by other classes that takes in a value intended for a private property. Since the property is private, a public method in that class will have access to the property and can set the value. The fourth way is by making the property public, which allows any class to set the value. Making all properties public is a common mistake made by junior level programmers. Let's consider the imaginary bank you own from the earlier examples on access modifiers. How would you feel if we made all rooms and all items of the bank available to the public? Should we let the customer know how many teller stations are in the bank? The number of teller stations is not a big secret. Should we let the customers know the contents of the safety deposit boxes, or how much cash is in the vault or teller drawers? Some properties are meant to be private. As I mentioned earlier, there are four common ways to set a property value. Making the property public should always be your last choice. There are three common ways to get the value of a property. The first is getting the value in a method for internal use. The second is by using a getter. A getter is a method used by other classes that returns the value of a private property. The third way is by making the property public, which allows any class to get the value. Understanding all the property options might seem confusing at first, but let's consider a few key points. This lesson was to introduce you to the property and many of the available options. Later we will discuss the proper usage of these options. I will also try to show you improper usages for your awareness. For now, I encourage you to make all properties private. In the payroll class, let's create a getter and a setter for the hours worked property. First, let's collapse a couple of these constructors. Make a little bit of space. Remember, a getter and a setter is nothing more than a method with a get or an set in front of the property name. Notice the naming convention, get hours worked and set hours worked. The getter has the same return type as the property and just returns the value. The setter takes one parameter of the same type and sets the property with the value passed. Most IDEs offer an easy way to generate getters and setters for properties. Let's delete all the getters and setters in the payroll class. Let's right-click on an area where you want to insert the getters and setters. Select Generate. In this menu, select Getters and Setters. Highlight all the properties that you would like to generate this code for. Click OK. Notice that all the code has been created for the getters and setters. You should now have a basic understanding of how to create a property along with the getters and setters. You should also have an understanding of access modifiers. Over the last 3 lessons, we have covered the basics for the class, constructor, methods, properties, and access modifiers. Your optional homework assignment is to build 2 classes in the same package and test the access modifiers. Build a class in a different package and test the access modifiers. In the next lesson, we'll discuss variables and data types. Remember, future senior developers, make it work, prove it works, then make it better. Ready, break!